What's up, everyone? Today we are going to learn about mass-to-mass stoichiometry. So what is mass-to-mass stoichiometry? Well, a little background. Yesterday we did converting between moles and grams, but it's not really useful because in the lab, right, you can't really measure things in moles. So it's more useful to convert things to grams from grams. So that's mass to mass. Essentially, what this will allow us to do is if we can measure out a chemical, for example, then we'd be able to predict how much product we make from a given amount of reactants. And that's exactly what you'll be doing in a future lab. Okay, so let's see how we do these kinds of problems. It's similar to the stoichiometry that we learned yesterday with one added step. Okay, so the added step is in blue here. So that's 3 different conversions, okay? Usually we're given the mass of one chemical and we want to find the mass of a different chemical. So the first step is the new step. We want to start by dividing by the molar mass of the given chemical. So in other words, we're converting from grams to moles, okay? Then this is just like yesterday. We're going to use the mole ratio. That's moles to moles. Remember that comes from the coefficients. Very important to look at the chemical equation when you do the mole ratio. Once you have moles of the chemical you want, then you simply multiply by the molar mass to get grams of the chemical you want. So the last step is going from moles to grams. We're going to do 2 practice problems, and then you'll have 2 problems to do on your own. All right, so let's take a look at this practice problem here. Same equation we looked at yesterday. I wanted to keep it simple. So how many grams of water are produced from 96 grams of oxygen gas? So as always, start with the given information. That's a great place to start. We've got 96 grams of O2 gas. So if we look at the steps, it says divide the given mass by the molar mass of the given chemical. So we are given oxygen. So I'm going to divide by the molar mass of oxygen. So oxygen is 16, and if I multiply that by 2, I get 32 grams. Okay? So this is going to give me our first answer to the first conversion, 3 moles of oxygen. Okay? So we're trying to work our way all the way till we can get grams of water. So we're still in oxygen. So what we have to figure out is now we have to get to water. So we're going to take those 3 moles of oxygen and we're going to do another conversion. This time, right, we want water. So I'm going to put moles of water on top, moles of oxygen on the bottom. And again, this is what we call the mole ratio. Remember, the mole ratio comes from the coefficients. So if we look in front of water, we've got 2 waters for every 1 oxygen, right? Think of this as like your recipe, right? If I want to make water, I need 1 oxygen, and that'll make 2 waters. So if I have 3 oxygens, then I can make 6 waters. So, sorry, that's going to be 6 moles of water. Okay. Now that we have our 6 moles of water, we can finally do the last conversion, which is to get grams of water. So the last step is to convert to grams by multiplying by the molar mass of water. So the molar mass of water is going to be 2 hydrogens plus 1 oxygen. So that's going to be 18 grams per mole for H2O. I'm going to put that number here. And then lastly, 6 times 18, I will get 108 grams of water. Okay, so again, I just did those 3 steps listed above. And I got my final answer here, 108 grams of water. So let's do one more problem, and then you can try 2 of them on your own afterwards. So here's a different chemical equation. We've got the combustion of propane gas here. How many grams of carbon dioxide are produced from 88 grams of C3H8? It's always a good idea to just make note of what you're given and what you're trying to get to. So for example, I know that I'm given 88 grams of propane here. So that's going to be my first conversion. And I know my final answer, somewhere down here, I'm trying to get grams of CO2. Okay? Somewhere. This is going to be my final answer. So we're going to get to that. But first, before we can, let's do this conversion. So again, first step, we want to divide by molar mass. Okay? So I've got grams of propane, so I'm going to put grams of C3H8 back on the bottom so that I can get moles of C3H8. So again, the molar mass we want to calculate. There it is. The molar mass of C3H8, well, each carbon is going to be 12. So I'm going to do 3 times 12 plus each hydrogen is 8. So if I bring that here, there's 8 times 1. Well, that's 36 plus 8, and that's 44 grams per mole. Great. So that number goes on the bottom. Again, that's the molar mass of propane. Well, look, 88 divided by 44. I think I can do that math. That's 2 moles of propane, C3H8. Cool, that was the first conversion. The next conversion, so we're going to take that answer, carry it on to the next part. The next conversion, right, we want to get to, eventually we're trying to get to carbon dioxide. So to change chemicals, right, we have to go through the mole ratio. So we want moles of carbon dioxide. We have moles of propane, C3H8. And so next step is mole to mole using the mole ratio. So again, the mole ratio comes from the coefficients. So I've got 3 carbon dioxides for every 1 propane. So I'm going to put 1 propane on the bottom, 3 carbon dioxides on top. 2 times 3 gives me 6 moles of carbon dioxide. Okay. So let's take that number now. And we're going to do our final conversion. Again, we're trying to get to grams of carbon dioxide, so we definitely want to put grams of carbon dioxide on top here. Units we started with moles of carbon dioxide. And so our last step is to multiply by the molar mass. So now we want to find the molar mass of carbon dioxide. So that's going to be 1 carbon, which is 12, plus 2 times 16 together. That's going to be 12 plus 32, or 44 grams per mole for CO2. And so that number is going to go all the way over here into the top. 6 times 44. And I get 264 grams of carbon dioxide. I know that was a lot, so make sure you go back, pause the video, and try the last 2 problems on this worksheet on your own. All right, good luck. We'll go over this on